Hi guys, welcome to our fifth lesson on organic chemistry. In this lesson we'll be looking at how to name hydrocarbons, particularly alkenes. Now let's begin by checking out some facts about alkenes. Okay, so alkenes or alkenes have a general molecular formula CnH2n. That means that for any alkene, the number of hydrogen atoms is twice as many as the number of carbon atoms. For example, ethene, C2H4, that's the molecular formula. Butene has the molecular formula being C4H8, and then heptene, C7H14. So when you look at all these three critically, you realize that they agree with the general formula CnH2n. Now, another fact about alkenes is that they always have a double bond in them. So any alkene compound should have at least one double bond in it, and then this double bond must be between two carbon atoms. And you should know that the two carbon atoms involved in the double bonding always have to undergo sp2 hybridization to make the bond possible. Now, alkenes are regarded as unsaturated hydrocarbons. That means that they don't have the maximum number of hydrogen atoms in them. So here's an example to illustrate that. Here you have an alkene compound and you can see that it has 4 hydrogen atoms. There are reactions that can take place to add onto this alkene compound more hydrogen atoms. That is when the double bond goes away for a single bond to be formed between the two carbon atoms. In order for them to achieve octet state, they have to bond with more hydrogen atoms. So you realize that the alkene did not have the number of hydrogen, a maximum number of hydrogen atoms possible. Okay, so now you should know that we have straight chain alkenes and branched chain alkenes. But in this lesson we would name straight chain alkenes, only straight chain alkenes. We'll be dealing with branched chain alkenes in later lessons. Alright, so when we're naming straight chain alkenes, you need to know first of all the root word, and then the root word always depends on the number of carbon atoms in the compound. So here are examples of root words that we'll be dealing with. Okay, so here I want to mention that we don't have any alkene that has only one carbon in it, because for any compound to be an alkene, it has to have at least two carbon atoms because of the double bond. Right, so there is no alkene with this root word meth, meth. The simplest alkene has 2 carbon atoms. Alright, so when you are naming after your root word, you have to know the suffix you have to be you'll be using. So all alkene names end with ene. That is the suffix. And then when we are naming an alkene, you have to indicate the position of the double bond. We know that there is a double bond somewhere in the compound, so you have to use a number to indicate the location. So let's move on to some examples. Here is our first example, C2H4. Now that's how the open structure formula looks like. So we can have the condensed structural formula as this. Now in naming it, we count the number of carbon atoms to determine the root word to use. So here we have 1, 2. We have 2 carbon atoms, so the root word we'll be using will be ATH. Now, the suffix is ENE because it's an alkene. See that there is a double bond. It's an alkene, so the suffix is ENE. Now, the bond position. What bond position are we going to give for this compound? Okay, all right, so here you can see that the double bond can only be found in this position, so there is no need to indicate the bond position. We have only 2 carbon atoms, so we not indicate the bond position. So the name is going to just depend on the root word and then the suffix, and there we go. Ethene, that is the name for our compound. Ethene can also be called ethylene. Alright, so moving on to our second example, we have C3H6, that is our compound. Now, that is the open structural formula. Let's see if okay, alright, so that's the condensed structural formula. The root word is going to be prop. Why prop? Because we have 3 carbon atoms, 1, 2, 3. Okay, and then the suffix obviously is ENE, and then bond position, the double bond position, let's count and see. Alright, so the double bond position is the number for the carbon that the double bond comes after. Alright, so here when you count from the left to the right, 1, 2, 3, realize that the double bond comes after the first carbon. So the double bond position is going to be 1. But you can also try to count from the right to the left to see if you have a different number for the position. So let's count from right to left. 1, 2, 3. So when you count in that direction, the double bond would come after the second carbon. So the position is going to be 2. So we have 2 options to choose from, 1 and 2. We always go for the lesser number. So the double bond position is going to be 1. Now the name would be 1-propene. So the name is made up of the bond position is 1, then a hyphen followed by the root word, then it ends with the suffix ENE. So that's the name for this compound. It can also be written as this, where the bond position comes in between the root word and then the suffix. So the name would be prop1ene. So any of these 2 is accepted. Now, third example, C4H8. That's the open structural formula. And here we go with the condensed structural formula. Alright, so the root word is going to be but. Why but? Because of the 4 carbon atoms present. 1, 2, 3, 4. Okay, then the suffix is going to be ene, E-N-E. And then the bond position, let's see, it comes after the first carbon. Okay, don't try counting from the right here because it's going to be 3 when you count from right to left. So we go for 1. So the double bond position is 1, and the name would be 1-butene or but1ene. But1ene. Okay, example 4. Here there is something fascinating. You can see that the molecular formula here is the same as the previous example, the example we just did, but the structural formula, the open structural formula, is different. So this is a phenomenon we call isomerism. It occurs when you have 2 or more compounds which have the same molecular formula but different structures. Alright, so here in naming it, we first count. There are 4 carbon atoms, so boots. Alright, for 4 carbon atoms. Then the suffix is ene. Now the bond position, let's count from the left to the right. 1, 2, 1, 2. So it comes after the second carbon. When you count from right to left, 1, 2. It comes after the second carbon. So either ways, our bond position is going to be 2. Okay, so the name is 2-butene or but2-ene. Now our fifth example. In this example, we are skipping the opening structure formula and then we go into the condensed structure formula. Okay, so C6H12. How many carbon atoms? 1, 2, 3, 4, 5, 6. So hex, the root word is hex. The suffix is ene. And in the bond position, let's count and see from the left to the right first. 1, 2, 3. So in that direction, the double bond is going to be have the position 3. Now when you count from right to left, 1, 2, 3, the double bond will come after the third carbon, so the position will be 3. So in both directions, we have 3 being the double bond position. Hence, the name is going to be 3-hexene or hex-3-ene. Alright, so example 6, C9H18. Here we have a very long condensed structural formula. Now, the number of carbon atoms is 9, so none is going to be the root word we are going to use, none for 9. Now, the suffix is going to be ene and then the bond position. First of all, let's count from the top here. 1, 2, 3, 4, 5. So in that direction, the double bond position is 5. Now let's count from the right to the left. 1, 2, 3, 4. In this direction, the double bond position is 4. So which one do we choose? You have 4 and 5. You go for 4 because 4 is less than 5. So the double bond position is 4. Hence, the name is going to be 4-nonene or non-4-ene. Alright, so this was the last example. Last but not the least, now it is time for you to try your hands on these questions. You have 1, 2, 3, 4, 5. These are names of alkenes. For each of them, I want you to write the molecular formula, appropriate molecular formula for each of them, and then draw the open structure formula for each. And then lastly, you have to determine the condensed structure.